radical expression contains a radical such as a square root. Now remember, expression means there's not an equal sign. Okay? The expression underneath the radical sign is called the radicand. Wow, I spelled that wrong. I knew that wasn't right. There's no N in the front. Radicand. So we talked about the discriminant was that piece in the quadratic formula that's underneath. That's exactly what a discriminant is, a radicand. Okay, it's underneath that radical. So our whole goal today is to simplify radical expressions. A radicand, or what's underneath there, is in simplest form if the following three conditions are true. Number one, no perfect squares other than one. No perfect squares other than one. No fractions. And no radical in the denominator. And we'll talk about what all of these mean here in just a minute. So they're going to give us a square root today with a number underneath. And we need to simplify that. And we need to simplify it as far as we can where there are no perfect squares other than one. You cannot have a fraction underneath, and there cannot be a radical in the denominator. So the product property of square roots tells us the square root of a times the square root of b is really like multiplying those two numbers underneath the square root. So like the square root of 2 times the square root of 3 is actually the square root of 6. Follow me? They're both underneath the radical, so technically you can multiply them. But actually what we're going to do is we're going to reverse that. They're going to give us a single number on under the radical, and we are going to break that down by using a factor tree. Remember, a square root means a number times itself can come out of that. Like the square root of 4 is 2 because 2 times 2 is 4. Now the square root of 80 is not a perfect square, but we can use a factor tree to break it down. I want to get this down to the prime factors. How do you want to break down 80? 40 and 2. 40 is 20 and 2, and 20 is 10 and 2, and 10 is 5 and 2. Now, if I were you, drag all of these down so they're on the same row. You know you are correct if you go 5 times 2 is times 2, times 2, times 2. You get back to your original number. That means you've done it correctly. Okay, so the square root says you can break it out of jail as long as you have 2 of them. Okay, so I have 2 2's. Agreed? So I am going to circle these 2 2's, and they're going to break out from underneath that radical, and we're going to write it down one time out front. Do I have another group of 2's? Yes, these 2 are also going to break out of jail and go out front. The deal is 5 doesn't have a buddy. He doesn't get out of jail. So he's still underneath the square root. 2 times 2 is 4. So this is really 4 times the square root of 5. Okay? Now, the thing about this is, really, you can break down 80 as 16 times 5, yes? Somebody check me, 16 times 5? Okay? And our rule up above says we can separate these really like this. Well, what is the square root of 16? 4. Square root of 5 is not a perfect root, so that's why I end up with this. But chances of you knowing that 16 times 5 off the top of your head is going to work is slim to none. So if you use a factor tree, every time a number is multiplied by itself, it breaks out front. If you take the square root of 80 in your calculator, what do you get? 8.94427,491. Okay, now type 4 times the square root of 5. Okay, and I know this is simplified because 5 doesn't have any perfect squares other than 1. It's not a fraction, and there's not a radical in the denominator.
What do you mean by like square? Is that like 16?
16 is a perfect square. Okay, so let's go to this one, 54. Break it down. 9 and 6. 9 breaks down as
3
and 3, and 6 breaks down as
3
and 2. Do any of those numbers have a buddy?
Mm-hmm.
Which one? Okay, so these 3's get to break out of jail. I write them down one time. Anybody else? So these two numbers are stuck in jail as 3 times 2. Now what is 3 times 2? So we have 3 times the square root of 6. All factor trees. Try 180 on your own. Now your process along the way may have looked different than mine, but on your bottom row you should have a 3, a 3, a 2, a 2, and a 5. They may be in a different order. Okay, so I have 2 3's. I write it down one time. They broke out of jail. I have 2 2's. I write it down one time. They broke out of jail. 5 doesn't have a buddy. He's stuck. 3 times 2 is 6 times the square root of 5. That is what you should get.
Wait, because I did 60 and 3.
When you that okay. Keep breaking it down though. You should end up with 2 3's, 2 2's, and a 5 on the very bottom row.
Oh, I didn't do the.
Yeah. Ultimately, you're trying to get to prime factorization. Absolutely. I'd right away just guess a 2 or a 3. And then a 5. Those are my things. If 2 doesn't go in it, 3 doesn't go in it, check a 5. Because you're trying to get to prime factorization. So Jackson said I'd just start with the smallest number you can. And that's what you're trying to break it down to. Okay? What happens here? The square root of 2 times the square root of 14. Okay? So because they're both under the square root, I can actually multiply them together. What is 2 times 14? 28. Now to make sure that I can simplify this, I'm going to make a factor tree. Which really, what'd you just say? 14 and 2, right? And 14 breaks to be 7 and 2 to 7 breakdown? No? Okay. Do you have a pair? A pair of 2's. Write it down one time. Goes out front. 7 doesn't have a buddy. Try the next one. Square root of 5 times the square root of 10. Now I know some of you are thinking this is really silly, Miss Hoff, that I'm multiplying together and then re-breaking them down. So what you easily could do is just put them under 1, right? And go 5 and 10. Follow me? Yes. And 10 breaks down to be 2 and 5, and this 5 comes down. Do you have any numbers that are the same? 5 and 5. It doesn't matter that they're not next to each other. This 5 and this 5. I write it down once, and then my 2 doesn't have a buddy. So I have 5 times the square root of 2. Do the last one. 6 and square root of 6 times the square root of 8. I got 4 times the square root of 3. Yes. Now, I intentionally broke this down in a weird way because most of you probably didn't go 24 times 2. But my point is it doesn't matter which way you break it down because you're going all the way to prime factorization, it's always going to get you the same answer. Okay? What happens when I throw in some letters? Consider the square root of x squared. You should automatically recall that the square root is the inverse of a squared number. Square root undoes the squared, right? So really the square root of x squared is x.
Yes.
Why is that assumption incorrect? It's incorrect. Nope, not a trick question. Easiest way to prove something wrong is to give me an example. Somebody give me an example of the square root of a number squared where it doesn't equal the original number. Maya. Throw something out at me. We'll talk about it.
49.
So the square root of 49 could really be written as what? The square root of 7 squared, which really is 7, right? These cancel. That proves it correct. So give me an example, Meg. So if I did like the square root of 4, I really could rewrite that as -2 squared, yes? But technically, when you take that square root, if I don't put that negative in there, how am I going to know that? Follow me?
What if it was just a normal 2 squared?
Then it would work. But we're trying to think of why is that incorrect. So negatives are going to throw us for a loop. Okay? Negatives are going to throw us for a loop because it may change whether it's a positive or a negative. Okay? Here's the rule. If it starts even power, yeah, let's do that. Let's actually, yes, you're correct. That's where I really want it. If it starts with an even power and ends outside with an odd power, must use absolute value. Okay. Okay, remember, x squared we could really put in a factor tree, yes? I could make this a factor tree of x and x. Everybody follow me with that? Do I have a pair of the same things I could break out of jail? Yes, I do. Hi. You can pick any 3 of those desks. Right, that or right here. So when I break it out of jail, what happens to it? When I broke numbers out of jail up here, what happened to them? They go out front, right? Okay, so really this answer is just x. When it started, was it even or odd? Even. If it starts even and ends outside with an odd power, doesn't have the square root anymore, what's the power? Is that odd? What do I need? absolute value. Let's go to the next one.
This one does not start.
X cubed really could be x, x, and x, yes?
You can break it into three.
Sure.
It's an X.
Do you have a group? Okay. I have a group. What do I do with it? Put it out front. But what do I have remaining?
Another X.
So I still have the square root of x in jail. If it starts with an even power, does it start with an even power? Then I don't have to worry about it. Okay? X to the fourth is really x times x times x times x. Do you have a group? I group them, I write it down. I group them, I write it down. I don't have anybody left in jail. What is x times x? X squared. Now, what's our rule? Did we start with an even power? Did we end with an odd power? Okay? No absolute value. This is my answer. I don't know about you guys, but I don't want to write out if they give me an x to the 12th, or even in this case where they give me an x to the 6th. So think to yourself, I have 6 x's lined up. How many groups of 2 am I going to have? 3. Are there any leftovers? So the leftovers would stick inside the square root, but I don't have any leftovers. But check. Did you start with an even power? And on the outside, is it odd? You have to have absolute values on that one. Okay, I'm going to give you one to see if you have to really write something down. The square root of 12 x cubed y to the 8th. I want you to simplify this. Put together everything we learned on the front, everything we learned on the back. You're going to break this all down. So I worry about the 12. I broke my 12 down to be 3 and 2 and 2. So I have a group of 2s. Where are they going? Out front. Now, my 3 is still stuck in jail. Now I'm going to my x cubed. How many groups of 2 can I make? 1. So he's going out front. How many left over are there? 1. Y to the 8th. How many groups of 2 can you make? 4. How many leftovers are there? None. The last thing we have to check, did any of these evens end up with an odd? Done. Normally you wouldn't have this gap in here, but I spaced it out. Reducing radicals. Yes, you have work to show me. Yes, I have more grid paper. Yes, your homework assignment is in ALEKS. I switched you back to the Algebra 1 textbook, so it may give you a weird screen and make you do the tools tutorial real quick, but it should not make you do a knowledge check. If it does, click I don't know until it goes away. The rest of the hour is yours to work.